close that gap. So I'll just show you that there is a gap here. So the piston is locked. There's water inside the cell. Now I have the valves here. There is a bottom drainage. So there are two drainage lines at the bottom and two drainage lines on top. So this is the top. This is the bottom. They're labeled here. And this is where the cell pressure, the outside cell, is being applied. And there's a vent too here. So first thing I'm going to do is I am going to connect my cell, and then I only need 2 flow pumps to run my triaxial, and this is going to connect to the bottom of the sample. So this video clip just shows you how I put my triaxial. I get it as close as I can. Everything is set here. Okay, this video clip now is going to talk in a similar way that we talked about the low track 2 unit. Is going to talk about the flow track, how this flow track works, and what you're going to do with it, and what's the principle and the keypad here and the functioning of that. Now, the flow pump here, the principle is that it just looks like a medical flow pump, where you have a piston inside a cylinder. The capacity of this flow pump is 250 cc's, which is about roughly the size of a can of a soda. And so that's how much volume of water you can hold inside. Now, at the end of the cylinder, you have a pressure sensor that is mounted internally. The pressure sensor has a capacity of 200 psi. For people who are familiar with SI units, is about 1400 kPa. So for 200 psi, that's a pressure sensor that is mounted internally. And there are 2 valves at the end of the piston. This is what we call the supply valve, where we supply water, and the output of it is on the back, and it uses a 1/4 inch tubing. And on the front, there is an output valve. So there are 2 valves. There are solenoid valves that opens and closes automatically, so you don't have to worry about closing for doing end drain tests or opening for doing drain tests. As soon as you tell the test that is end drain, it will take it from beginning till the end with opening and closing valves automatically. So this is a full automated system. Now, this flow pump, as I said, at the end we have a pressure sensor. So when it's pushing in or pushing out, is measuring the pressure inside the cylinder. Now, the volume of water that comes out of the pump is measured indirectly by looking at the micro steps, the travel of the piston inside times the area of the piston. That gives you the volume change. So it automatically measures all the pressures, all the volumes, and those results are recorded too during the test from beginning till the end. So what you need to do now to make this flow pump work is that the connections to the flow pump, you have the power network, and then you have a supply. You need to provide a supply of water that preferably is de-aired water. So you get the 1/4 inch, you make sure you dip it inside, so you got your water supply. After certain use, you might want to change the water. Just you don't want to wait until it turns green, like the water over there. Then the output valve is here, and we have 1/8 of an inch tubing. And what we're going to do, this uses the same principle. As I said before, what you can do here is exactly same as doing it with the low track, and then whatever I can do here, I can do it through the computer interface. Now, I can open and close the valve manually, I can push water out or try to take water in manually here. What you're going to be doing is you're going to make sure you saturate the lines so you don't have air in the line when you run the test that you're going to be putting air in your sample. So what you're going to do here is first you want to make sure that your pump is filled with water. So you go into the menu and position. Remember there was a position where you raise the platen or you lower the platen. Here you're not raising, you're pushing the piston in or you're pulling the piston out. So when you pull in the piston, that means you're generating pressure and you're pushing water out. Either you can push the water out of the supply or you can push it out of the output. You decide that. We're going to be pushing it through the output here so we can fill in all this line here. The first thing we want to make sure that there is water. So I go into position here. If I go first to monitor system, that tells me is 50% full. What I'm going to do here, I'm going to pretend I'm starting from scratch. I go to 2, position, and I said I'm going to empty because I don't know what's inside. So I'm going to empty all the water and then fill it. So I go to empty, I hit 1, I do enter, and it says flow out. And there's water coming out from the tube because there was water. So the water is coming out, so it's emptying. Now it's going to go all the way until it hit limit switch, empty, and it will stop. So it stopped. I put it back in here, and it hit limit switch. Now what I'm going to do, I'm going to go to escape, and I do fill. Now it's filling. You notice there's a difference in the sound. When it's pushing, it was creating a positive pressure. And it's pushing water as fast as it can, it's all positive pressure. When it's filling, it's creating a vacuum inside. And if it's too much vacuum, that can damage the pump. So there's a feedback here. It keeps tracking, monitors the vacuum, and it's going as slowly as it can. So you cannot control the speed of filling the pump because this is a safety measure to prevent any what's called cavitation problems that might occur with vacuum. So now it's filling the pump, and it will fill it all the way until it hit limit switch. We don't need to fill it all the way. We can stop it at 30%, 50%. We don't need all that much water. But if I want to stop it, I do escape, and it will stop. I can look how much water is here. It's about 13.7%. Another way of filling the pump at 50% is called initialize. Here on the low track, when you initialize, the piston goes all the way down, hit the limit switch, and goes up, so it gives you the full range. Initialize here, what it does, if I hit initialize, it will empty the pump, and it will fill it to halfway, 50%. Why is that? Because when you run a triaxial, sometimes the soil, if it's spongy, wet, it will give out water when you put pressure on it. So you want to make sure there is room in the pump to take in water. Sometimes if the sample is totally dry, you're pushing water inside. So you want to start with enough water so you can saturate your sample. So by default, when you do initialize of this pump, I can initialize all this pump here, same way. It will empty, clean up all that, and it comes back to 50%. Now this is manual mode. On the computer, when you run a triaxial, before it runs the test, it will ask you if you would like to initialize the pump to make sure you have enough water so the test will be completed successfully. Now, you do have control how much water you want to fill in the pumps. You can say 75%, 50%, 60, any value. Based on what? Based on the size of the sample and is initial degree of saturation. If you're not sure, just put 50%. Now the water, you see flow in, flow in, flow in, that means it's sucking water out. You want to make sure that those lines are all the way at the bottom and you're not sucking air inside the pump. That can create a problem later on. You don't want to be pushing air in your sample when you're trying to saturate it. But right now what I'm going to do, I want to saturate this line. So what I do is I go into control valves, number 5, menu, and I'm going to open the output valve. You see this valve here, output valve? I hit 1, it will open. Now I have the supply valve open and the output valve. Because this one is higher than this one here, I can wait. I can go down here and let it drip. And it will eventually, water will go from this reservoir water, go to the pump, and come out. Here, it will start to drip here. But I don't have time to do that, so what I'm going to do, I'm going to push it. So what I do is I'm going to close the supply valve, which is number 4 here, and I'm going to escape and do jog and hit flow out. And then I wait for the water to come out. And with all the air that is inside here. See, there's water coming out. So in my line, I'm saturating the line using the jog. So I can stop it now to escape the jog. So my line is saturated with water. My output valve is open. The water is not going to be dripping because there's only one valve open. If I open the supply valve now, it will start to drip out. But I'm not going to do that. So there's water inside. I'll make sure that there's no air trapped here, which looks good here. Since my line is full of water, and I can go to monitor system, I can see my pressure here, and if I raise this pressure here, if I raise it about 28 inches, I see about 1 psi. So that's another way of checking that the sensor is calibrated correctly. In this video clip, I'm going to show you how you set the 0 values for the sensors that they are involved with the triaxial test. Now when you run a triaxial test, you have a frame that has 2 sensors. One is a load cell and one is a displacement sensor. The load cell will measure the vertical or the axial stress on the sample. Displacement is deformation of the sample. Now the displacement, you do not have to zero it. The software automatically zeroes your displacement sensor. So nothing to worry about. The displacement sensor is mounted underneath here and is set, and you forget about that. Now the load cell can be zeroed by changing the offset value to the value that you read when there is no load. So what you do here, you go into the software, you load your template file. So you go to File, load your template here. Then you go into View, System. You look at the load cell, you see it's reading 32736 in terms of analog reading. And I know that there is no load on it. It should be reading 0 because it's not touching anything, just hanging in the air. So what I do, I go into Calibrate, Summary, and Load, and I override that offset by typing 32737. That's the value that is here. Then I say Apply, Download. It will download it there, so they will be in sync between the PC and the load frame. I do OK. Now I see my load cell is reading 0, fluctuating about plus minus 0.1.